welcome back to our news Chem Corner. I hope you are doing well. Today is all about sharp exam ready MCQs to test your concept and speed. Think fast, answer smart, and don't forget to share your score in comments. Let's jump into the question. So let's do this one. You can read the question, pause the video, and try to answer it. Then check with my answer. Okay. So the first one, 2Ag plus Cu gives 2Ag plus 2Cu2 plus some reaction is there. The recell is also given, and a silver copper galvanic cell is set up. Okay, and the above reaction occurs if all other variable were to remain the same. What is the one way to increase the cell potential? Okay, so we need to increase the cell potential. Correct. So every time if you are increasing the cell potential, then you have to do some forward reaction. Only forward reaction facilitating the cell potential, right? Because for the reaction, by the reaction we got this E cell. So always E cell will be higher than the E0 cell for a forward reaction, like forward reaction facilitating thing. So which one is the following favoring for the forward reaction? First one, increase the mass of copper electrode. See, we are not doing anything with a solid substance, right? Okay, increase the mass of silver electrode. So also you can omit that one. Then increase Ag plus. What happen if you are increasing Ag plus? Definitely the system will try to decrease it. So they will do some more forward reaction. So definitely option C will be the answer. Okay. So the second question, use the following answer to answer the question 24 to 27. Okay. So they were given with the titration HN3 hydrozoic acid and NaOH, a strong base. So it's a titration with a HN3 and NaOH. Okay. So what may be the product? They were given already the reaction. This is the reaction. Right. Then 25 ml of hydrozoic acid HN3 is titrated with 0.5 molar NaOH. pH is measured during the titration producing the above graph. The equivalent point is reached out at a volume of 20 ml of NaOH. Okay, what is the concentration of HN3? So concentration of acid, initial acid, how do you do? You can directly use M1V1 is equal to M2V2 for a 1:1 thing. Otherwise, you can generally use number of H plus times M1V1 is equal to number of OH minus times M2V2. Okay. If it's a diprotic or triprotic, you can use the general equation like this, or simple stoichiometry. By using simple stoichiometry also you can do that one. So anyway, I'm just using M1V1 is equal to M2V2, right? Molarity we need to find. Here it's a monoprotic and mono basic acid and base, so no issue. Then volume of HN3, it's a volume of HN3 25 ml. They were initially took a 25 ml. Correct? So you can apply 25. Here not want to even convert it to the liter. You can directly apply the ml. Okay, OH is here again 1, NaOH is actually. Then M2 molarity of NaOH, do they given? Yes, they were given, it's 0.50. Okay. Then V2 is actually the endpoint volume. They were given it's 20 ml. Okay, so after all what we need is, yes, 0.5 times 20 divided by 25. Okay, so what's the answer? Yes, we got A. I hope you got the answer. Okay, we can move on to the next one. It's a part of the same question. At what volume of NaOH added would N3 minus is equal to HN3? So what is this N3 minus? See the reaction? This is the reaction. So N3 minus is nothing but the salt, right? Salt. So salt is N3 minus. So where you can find this salt concentration is equal to the HN3. We studied the graph acid titration. So everything like acid titration I am already described in another video. So you can check my video. In that one I am already given how each point of the graph I am already described. So you can check with that video. Okay. So here we know that the initial point is what? Full of that HN3. Before titration, before the equivalent point, the thing will be buffer. So this all are buffer because it's a weak acid and strong base titration. Okay. And after that equivalent point, so here the salt will be the dominant thing. So N3 minus is actually after the endpoint, who is there? Yes, our strong base NaOH will be there. So these are the areas. So see, HN3, the acid you can see only up to the equivalent point, right? After that HN3, after the equivalent point, there is no HN3, right? So here HN3 have to equal with the N3 minus. So definitely it's a below the equivalence point, right? You know the exact that point. It's a halfway point, right? Halfway point we studied HN3 is equal to N3 minus. If any doubts are there, you can check my video. We already described everything. Okay. Before the halfway point, you can say HN3 is higher concentration than the N3 minus. Some question be like that. Okay. After the halfway point, N3 minus will be higher than the HN3. Okay. So this is simply the halfway point 10 ml. Okay. So that's the answer. Then next one. 26. Which indicator would be best to use determine the endpoint of the titration? So endpoint titration indicator equation like pH is equal to pKa you can use. So if you need a pH is what's the pH for this endpoint? See 20 ml is actually the endpoint. Our endpoint is corresponding to some 8 or 9, right? It's actually some 9. So we need a pKa of 9. So which is close to this one? Out of these values, you know, it's C. Correct? Always we need equivalent point pH should be equal with the pKa of indicator. Equivalent point pH is 9 here. So that you need a pKa of 9. So 8.9. Okay. Then next one, which of the four substances listed below would have the highest melting point? Okay, so highest melting point usually IMF, right? IMF. So ionic compound or covalent compounds, the IMF is their chemical bond itself, correct? Okay. So let's see here. This is ionic compounds, definitely high thing. High melting point will be there. This is also ionic bond. This is also ionic bond. This is a covalent bond. Don't want to think about covalent because covalent compound melting point is very lower. Then what about the among these one, which one is high melting point? You can think about higher ionic bond. Higher ionic bond means, you know, K plus and Cl minus interaction is what we call ionic bond. So if higher interaction means higher stronger the bond, so you need to put high amount of energy in order to melt the sample, correct? Okay, so at that time Coulombic force of attraction, which one is having this kind of opposite charge attraction is called a Coulombic force of attraction. So which one is having more Coulombic force attraction? That is always we are checking with the that lattice enthalpy, correct? That lattice enthalpy you can check with a charge over radius ratio. One with a having high charge and radius ratio, high charge over radius ratio, that will have a higher lattice enthalpy, like higher Coulombic attraction, correct? So don't want to take the exact ratio, you can just think about charge first. Which one is higher charge? Yes, here plus 1 and minus 1. KCl plus 1 and minus 1 only. CaBr2, yes, that is having plus 2 and minus 1, right? Right? MgO is plus 2 and minus 2. Okay. So what may be the thing? Yes, more charge will be this one. So first you give the importance for the charge. If charges are same, see for example instead of MgO, suppose it is MgCl2. At that time, then you think about the radius. Because at that time charges are same. Then look at the lower radius. Magnesium have the lower radius than calcium. At that time, magnesium chloride, MgCl2 will be the higher melting point. Okay. In this case, no issue, MgO. Got it? Okay. The next one. They were given some ion and ionization energy is given. Okay. The next ionization energy value for different ions of period 3 metals are listed above. The reason that the aluminum ion has the greatest next ionization energy is. So what do you mean by next ionization energy? See, aluminum is now it's already 3 plus. Next ionization energy means if you are removing another electron from this aluminum, so what they will become? At that time it will become Al4 plus and they release one electron. So every time when you want to remove an electron, you need to put energy. That energy is what we call ionization energy. So next ionization energy means now it is Al3 plus or Mg, now it is Mg2 plus. If you are removing an electron from this Mg2 plus species, it will become Mg3 plus and 1 electron. Right? How much energy is provided for that that process? So that is their ionization energy. Okay. So that energy, while you comparing, aluminum how highest. Okay. What is the reason? That is the question. Okay. The options are aluminum metal is less chemically active than magnesium or sodium. The radius of aluminum ion is the smallest. Okay. The aluminum ion has the greatest number of unpaired electron. Is it? Now everything is same number of electron, right? Because L3 plus all are isoelectric species. Okay. Aluminum ion experience the smallest amount of shielding. Shielding also same. All are isoelectric species, same number of electron, right? All the concentration, shielding effect is depend upon inner electron. Aluminum is also, what is the thing? 1s2, 2s2, 2p6, Al3 plus. Correct? Magnesium 2 plus is also 1s2, 2s2, 2p6. So shielding is only with this 1s electron. Correct? So that is same with the aluminum Al3 plus, Mg3 plus, Mg2 plus and sodium plus. Okay. Right. So what is the reason? You may already found. Yes, the radius of the aluminum atom, aluminum ion is smallest now. Correct? Because now all of them are 10 electron. But aluminum is 13 protons are there. Magnesium is 12 proton is there and sodium is 11 proton is there. So definitely you feel like the atom feel more attraction in this aluminum case. So it's very hard to remove an electron from this highly attracted species. So smaller radius for aluminum ion, that the aluminum 3 plus ion, that is actually making the removal electron harder. Okay. So the next question is NaCl is turned to Na plus plus and Cl minus. Okay. Sample of sodium chloride NaCl is dissolved fully in water. Which diagram below is an accurate representation of how the solution would look on the particulate level? Okay. Particulate diagram they were asking. So main point, NaCl when dissociate in water, they will dissociate like Na plus plus and Cl minus. And which one is smaller and which one is bigger size? That's the first question. And they were associating with the water. So water, which atom is associating with the which ion? That's a 2 point, correct? Okay. Na plus, sodium cation is the lower than the Cl minus. Left to right, atomic size increases or ionic size, sorry, decreases. Decreases. Okay, top to bottom, atomic size increases. But here Cl will be the higher in size because it's an anion, right? Anion will be bigger than their parent atom. Sodium is smaller than their parent atom because it's a cation. So definitely sodium is also in their original, like the size of the ion will be less than the original sodium atom. So that's why here Cl is not the smaller atom. Okay, it's not the atomic size. They were talking about ionic radius. Okay, so be careful. Na plus how will be Na plus will be the lower size. Okay, then what about the atom like H2O? H2O, oxygen is partial negative charge and hydrogen is partial positive charge. So partial negative charge oxygen have to attach with a sodium. Correct? Na plus ion. So which diagram, see the bigger size, that circle is representing oxygen. So yeah, the first one, right? Okay, so the first one is correctly representing the ion dipole interaction. Okay, then next one. Which of the following expression would accurately give the magnitude for the density of sample of helium gas at STP? So density we need, the thing is in STP. Okay, STP means quickly you can write 1 mole is equal to 22.4 liter. So mass of the thing they were not particularly given. So you can consider just 1 mole. 1 mole mass is 4 gram, right? Helium is 4 gram. That's the molar mass. And volume is corresponding volume. This is mass and the corresponding volume. This is 1 molar mass. So corresponding volume will be 22.4 liter. Okay. Oh, they were not given any option like that. Okay. So what is this 20.4? So, how we got this 22.4? PV is equal to nRT, right? So, pressure is 1 atmosphere at STP. Volume we do not know. And N number of moles is 1 we are considering. And R is 0.0821 and temperature, it's STP, so the temperature should be 273 Kelvin, right? 0 degrees Celsius. Okay. So the volume will be, this 22.4 is nothing but 0.0821 times 273. So yes, first option, correct? First option will give that one. Next one. In which of the four molecules below is the bond angle between the terminal fluorine atoms and the central atom the smallest? Okay, so here first one as tetrahedral geometry, right? This one you need to study that, the different cloud, how different shapes are there. So central atom with 4 electron cloud bond pairs, tetrahedral. So tetrahedral bond angle. And here central atom with 3 bond pairs, so trigonal planar. So trigonal planar bond angle is 120 and tetrahedral is 109.5. And tetrahedral with one lone pair, like, 3 bond pairs and 1 lone pair. So it's actually tetrahedral minus 1. Electron cloud is again tetrahedral, so the bond angle will be 109 actually, but you can just reduce 2 digit from one lone, since it's a lone pair, one lone pair is there. Okay, we are usually uh, reduce 2 digit like 107, like that you can think. Okay, from the actual bond angle. Clear? Actual bond angle, like tetrahedral, original tetrahedral bond angle is 109.5, so you can reduce 2 digit. Here again 4 electron cloud, so 109.5, but two lone pairs are there, again you can reduce some 4 digit. So which is the lowest one? Yes, D option, correct? Okay, then next one, CO2 plus H2 gives CO plus H2O. The K value is given. Using the above information, determine the equilibrium constant for 2CO plus 2H2O gives 2CO2 plus 2H2. Okay. So, when you manipulate the equation, what happened to the K value? What is the thing? When you multiply with some N value, the K will becomes, K nu will becomes K alt raised to N. Isn't it? And when you reverse the reaction, what happened? When you reverse the reaction, K nu becomes reciprocal of K alt, not like a Hess's law. Okay. And one more thing, when you add the reaction, the K is not get added, it just K nu will be multiplicate, like K1 times K2, like that it will change. Okay. So do not think of a thing like a Hess's law. Hess's law, delta H is just opposite. Like there we studied like multiplication means delta H is also got multiplied. Reverse means delta H sign is reversed. Addition means delta H is also added. But here it is not the thing. So yeah, in what way we manipulated? You can compare this reactions. 2CO is here. So yes, CO is in this reaction, it is the product side. Now it is in the reactant side. So we reverse the thing. So 1 over. Now our K will be 1 over 5.0 times 10 to the power of minus 3. And then one more thing they were given. It's multiplied by 2. So you need to put raised by 2. Raised to 2. Okay. So square. We are taking the square. So what's the answer? Yes. While you're doing this one, you can get the option. Okay. So that's all. How many did you get right? Drop your score below. Like, subscribe, and stay tuned for more MCQ drills and concept booster only on Anu's Chem Corner. See you in the next one. Keep reacting, keep learning. Bye.